Last time we met, we talked about 2x2 systems. Can you remind me why they're called 2x2 systems? Because there was 2 equations and 2 variables, right? However many variables we have, we talked about. However many variables we have, that's how many equations we need to solve the system, at the least, right? We can have more, but we need at least, in this case from Friday, we need 2 equations if we have 2 variables. And our answers look something like this, right? What's that called? An ordered pair. Okay, that was called an ordered pair. Today we're going to start 3x3 systems, which hopefully you can figure out means 3 equations and 3 variables. Absolutely. Okay, so our answers aren't going to look like this anymore because we have 3 variables. They're going to look something like this. Is that still going to be called an ordered pair? What's it going to be called instead? It's going to be called, an ordered triple. Because there's 3. Does that make sense that it's an ordered triple? Okay. So on page 60 in your book, there's several explanations. Remember we talked last time we met about the fact that if we have 2 equations and 2 variables, what we're looking for is where they cross. We also talked about the fact that they could not cross because the lines are parallel. Or we talked about the fact that there could be infinitely many solutions because it's the same line, right? That kind of thing can still happen with ordered triples. And on page 60 of your book, we look at several of the examples. We're not graphing lines anymore, are we? What are we graphing? A plane. That's exactly right. We're graphing planes, and in this case 3 planes, right? So do you see how these 3 planes are intersecting at one point? And that point is going to be our ordered triple, okay? But there are possibilities where we could have infinitely many solutions like this is, where the planes meet at a line. So that every point on that line is a solution to this system. Does that make sense? And there's also, in fact, 3 different ways that they show you down here at the bottom where they could have no solutions. Maybe these 2 intersect, and these 2 intersect, and these 2 intersect, but do all 3 of them intersect at one place? No. These 2, these 2 don't even intersect at all because probably they're parallel, but still there's no common point of intersection. These don't even intersect at all, nowhere. Okay? Does that make any sense? So that's the visual that I want in your head when it comes time to talk about the answer. Okay? Hopefully most of the time we're going to get something like this where we can actually find the point. Okay? So let's do a sample problem. What I want you to understand is that I am going to do problem number 12 for you. Look at the problems that you're assigned to do. 5 through 11. If I'm doing number 12, what does that imply? I'm not doing the easiest one, am I? Because usually the easiest ones are at the beginning, right? I'm probably doing a harder one. Okay? We're not those crazy teachers that gives you the easiest ones, 4 plus 4, and then ask you to calculate the sun as your answer in your homework by yourself. Okay? We're not going to do that here. I'm going to show you one of the harder ones so that when you do the homework problems by yourself, the ones you're doing are probably a little easier than the ones I show you. Or maybe on par with these. Okay? First of all, actually notice in your book problems 3 and 4. I did not give you problems 3 and 4 to do for homework because they're too easy. Okay? But what I know is that they show up on your review and one of them shows up on your test. So why am I giving you a super easy one on your test? Because I want you to pass. And if you get that one right, you know you got at least a 5, right? And if you came to the study session, you got at least a 10. Confidence builders, right? Okay. How would you do number 3 or number 4? Let's look at them real quick. Determine whether the ordered triple is a solution to the system. How do I figure out if this is a solution to this system? Plug it in. Plug it into the first equation. What's the mathematically correct word for plug it in? Do you know? Starts with an S. Substitute. Okay? Now, the reason I call that to your attention is because how are we solving this today? How are we solving these? Substitution, right? I want to make that connection for you. Okay? So we substitute this point into the first equation and the second one and the third one. And what has to be true? Exactly. It has to be true for all three of them. If it's not true for the first one, do you even have to try the second one and the third one? No, because if it's not true for the first one, it's definitely not going to be true for the whole system. Okay? But that's all you would do on 3 and 4. But again, I didn't assign those because they are too easy. Okay? You got it? So let's do number 12. Number 12 is going to require you to think. So I hope you brought your brain with you to class today. You ready? If we're solving this system by substitution, think back to the other day when we talked about this. What did we have to find first? A variable that was by itself. That's exactly right. Do we have in this system any variables that are by themselves? Now, earlier they said there's 3. They said there was this one, and they even said this one. Why do I not consider this one by itself? Because it's negative. I still would have to do something to get that y by itself. I'd have to divide everything by -1. So if I was doing this problem, and I am, I would choose either this y or this x, since it is not only by itself, but it's a positive value. Does that make sense? So, what's important for you to know here is when you're solving this system and you're trying to solve by substitution, it does not matter if you choose this y or this x to start the problem. So which one do you want to do? Okay, so I'm going to solve for this y. Why am I solving for this y? Because that's what she said. Okay, that's what she said. So how do I go about solving for this y? I have to isolate it, right? So it did say, let's see, can I add 3x to both sides? Can I do it by adding it above? I know that's not normal, but I'm trying to save some space here on my paper. Can I subtract 2z from both sides? So what I end up with is y equals what? -13 plus 3x minus 2z. Now, for the record, this kid asked me last period why I put a cross through my z. It's because sometimes I get writing my 2's so fast and I'm like so excited to do the problem that I get messed up about what's a 2 and what's a z, so I always cross my z's. Just so you know. You feel me? Okay, awesome. Now, do I know what y equals? Yes, but no, right? Yes, but no. I know that y equals this, but I don't know if y equals like 4 or 7 or -3, right? But I know a value that y equals. So what do I want to do with that value that y equals? If we're solving this system by substitution, I want to substitute it, right? Now, how many different y's do I have to choose from? I have 2 to choose from. Not the first one, because that's what I use to find y, right? I have this one and this one. Which one do I want to choose? Probably both of them. Probably both of them. And you'll see why in a second. Okay? So I'm going to start with this second equation right here. I'm going to bring it right down here. And I'm going to rewrite it. Except when I get to y, I'm not going to write y. I'm going to write what I know y equals. So I'm going to write 7x plus 2 times y. And what does y equal? -13 plus 3x minus 2z. And then I need to keep writing the equation, right? Minus 6z equals 37. Isn't that what the second equation says? Now what can I do with this? I can distribute, right? I can simplify this equation. So I want to distribute there. First of all, let me write 7x. And then I have minus 26. Everybody see where I got minus 26? And then I have plus 6x. And then I have minus 4z. And then I have minus 6z equals 37. Have I done anything difficult so far? So why do people hate these problems? Because they're long. Okay? You're going to be fine. Now what? I want to combine my like terms. I've got a 7x here and a 6x here. What does that give me? 13x. I've got a negative 4z here and a negative 6z here. What does that give me? Negative 10z. And then I have this negative 26. And then I have equals 37. Is that as simplified as I can get it? No, what else can I do? Very good. Add 26 to both sides. So that my as simplified as possible equation right now is 13x plus 10z equals 63. Absolutely. Thank you very much. I appreciate that. Catching my mistakes. Any questions about that? Can I do anything with that right now? No. So right now I just kind of ignore it, right? I simplified it as far as I could. Where did I get this from again? Remind me. I took the y and substituted it to the second equation. Now what do I need to do? Take the y and substitute it in the third equation. Okay? So my third equation is x minus y, but I know y equals a negative 13 plus 3x minus 2z. That's a weird z. I'm sorry about that. And then plus 3z, and then equals negative 14. Is there anything to distribute here? Like we did on the last one? Yeah, the negative. Isn't there like a 1 right here, a negative 1? So when I distribute that, I get x plus 13 minus 3x plus 2z plus 3z equals negative 14. You okay so far? What can I do with this? Add my like terms. I got an x and a negative 3x. Negative 2x. Then I've got a 2z and a 3z, 5z. And then I've got 13 equals negative 14. What should I do? Good. Subtract 13 from both sides. So I get negative 2x plus 5z equals negative 27. So notice please right here I have one equation with x and z. If I have two variables, how many equations do I need to solve that system? At least two, right? Do I have another equation with x and z? Where? Yeah, right here, right? This one? Can I pull those two out and make like a whole new problem? Like a whole new system of equations with just those two? Absolutely. I have 13x minus 10z equals 63. And I have negative 2x plus 5z equals negative 27. So what can I do with that? That's just like what we did on Friday, isn't it? The last time we met? Yeah? So I could either do, now I know the directions say solve by substitution, and when we're doing 3 by 3s, the important part about solving by substitution is getting that first equation by itself and substituting that in. At this point, I'm okay with you using either substitution or elimination. What do I want to multiply the bottom equation by? Because I heard you guys saying you want to do elimination, right? So if I rewrite the first one and get 13, that's weird. I have no idea. I'll have to mess with it. I'll mess with it in a minute. Oh, maybe. I don't like that. Yeah. 13x minus 10z equals 63. And if I multiply this whole second equation by what? What did you want me to multiply by? Why not negative 2? Oh, I already have a negative 10. I need a positive 10, right? So I have negative 4x plus 10z equals negative 54. What should I do with those two equations now? Just combine them. What's 13x minus 4x? 9x. What's negative 10z plus 10z? 0. What's 63 minus 54? 9. Oh my goodness. All that work to find out that x equals 1? Jiminy Christmas. You'll be fine. If you're going to cry, I do have tissues on my desk. Okay? Okay? Am I done now? I know what x is. I still have the other things. Oh my goodness. Where should I go to find another thing? How about right over here? If I substitute x in here, what will I find? Z. Isn't that something I have to find? Okay, here's a confusing point. This hasn't happened this year yet, but it has happened in the past. Okay? You do not have to find your variables in order. Just because we found x first, that's great. That doesn't mean I have to find y next and then z after that. I just have to find all three. Don't laugh. People have done it. Okay? So if I substitute, where do you want me to substitute x equals 1? Where do you want me to do that substitution? In the 13? Okay, so 13 times 1 minus 10 times z equals 63. Does anybody know what 13 times 1 is? Okay, thank you. 13. 13 minus 10z equals 63. So I have to subtract 13 from both sides. Negative 10z equals 50. Divide by negative 10. Z equals negative 5. Now I'm done. Now I had to find y. Okay, so I'm going to take, how about if I just go back to the very beginning right here? Because I already have y solved for. I mean, I could go back to one of my original problems, but since I already have y solved for, why don't I go here? Is that okay? So what I have is y equals negative 13 plus 3 times 1 minus 2 times negative 5. Okay, does anyone know what 3 times 1 is? Oh my gosh. Y equals negative 13 plus 3. What's negative 2 times negative 5? Positive 10. So what's negative 13 plus 3 plus 10? Y equals 0. How do I write my answer? We talked about it at the very beginning. How do I write my answer? As an ordered triple. Absolutely. What order do I write my ordered triple in? That's what has to be in order, right? That's the important thing, to be in order. X is 1, Y is 0, Z is negative 5. This is my ordered triple. How do I know that it's right? This is where I go back to my first problem, it's my first initial equations, and I substitute the points in. 1, 0, negative 5. Okay, watch this. Negative 3 times 1. Does anyone know what negative 3 times 1 is? Negative 3. Negative 3 plus 0. Negative 3. What's 2 times negative 5? Negative 10. Negative 3 plus negative 10. So does that one work? Yes. Okay. So 7 times 1. 7. What's 2 times 0? So what's 7 plus 0? 7. Okay, good. We're already doing better than last period. What's negative 6 times negative 5? Positive 30. What's 7 plus 30? Does that one work? Yes. What is 1 minus 0? I am so proud of you for not saying 0. Okay? 1 minus 0 is 1. What's 3 times negative 5? What is 1 minus 15? So does it work? How much of that checking did I write down? None of it. But did I do it? Yeah. So how are you going to let me know that you did it? You're going to check your answer. Look what I wrote. I wrote a check by your answer. Because that helps you remember that you should check it. Okay? Any questions? Are all of your homework problems as hard as this one? Absolutely not. Look at number 5. Look at number 5 right here. What does number 5 already tell you? It already tells you x, doesn't it? What can you do with x? Where? Plug it into the second equation. What's it going to tell you? Y. And once you know x and y, what can you do with it? Plug it into the last equation. Substitute it in, and you'll have all 3 variables. Hush. Hush. What about number 6? Same thing. Except we're starting with z this time. Do you understand what I'm asking you to do? So, for sure on 5 and 6, it's going to take you longer to write it down than it is going to take you to do the problem. Okay? I know that it's going to take you more than 1 piece of paper to do this homework. If you don't have 5 pieces of paper, I have 5 pieces of paper for you. Okay? So if that's something you're going to cry about, I do have Kleenex on my desk. Okay? Do you have any questions about what you're expected to do for your homework tonight? You have the rest of the period to work. Mark it, set, go. Peace.